Back once again. So this is question 9 of WAEC 2025 solution. So let's read the question, please. A liquid of mass 2 kg at 61 degrees Celsius is kept in a large vessel. So a liquid of mass 2 kg. Okay, let's write those parameters first. So the solution here to this equation, we have a liquid whose mass is 2 kg. So mass of liquid is 2 kg and the temperature of the liquid is 61 degrees Celsius. And this liquid is kept in a large vessel. So that means heat is not lost. If you are kept in if a substance is kept in a large vessel, it is assumed that heat is not lost to the surrounding. Okay, so the heat has been conserved. Okay, if another 2 kg of the same liquid, now you have another liquid, but they are of the same material, they are of the same substance. That means the liquid are of the same thing. And the mass is almost the same thing. That is true. So the other liquid, let me write it here. The mass of the other liquid is 2 kg. But the differences between these two liquids is their temperature, which you have the temperature 2. Okay, let me denote this with temperature 1 since they are of the same material. So since they are of the same material, I will just set liquid 1 and this is temperature 2. And that is 21 degrees Celsius, is added to the liquid in the vessel. Okay. So this new liquid of the same property as the first liquid, which was in the lag, were mixed together. So were mixed together. Now, this is heat. Is under heat and temperature. Okay, this is when you have specific heat, specific latent heat. In physics, we are meant to understand that when heat will be transferred whenever there is a contact between a lower temperature body and a hotter temperature body. Okay, so if you have a lower temperature and a hotter temperature body, heat will be transferred from the hotter one to the what? To the lower one. So if you look at this, the first liquid which was in the vessel is at a temperature of 61 degrees Celsius, while the second one is at a temperature of 21 degrees Celsius. Definitely, the one with 61 degrees Celsius is going to lose heat to what? To the one with 21 degrees Celsius. And from this concept, we now have that the first liquid is gonna be losing heat. So this is heat loss, and this is going to gain heat. So this is heat gain. Okay, and these two things will continue until there is a thermal temperature, there is a stable temperature. Okay, so 61 degrees Celsius will continue to lose heat to 21 degrees Celsius until there is an equilibrium. They both reach a particular temperature, which is the final temperature we are asked to find here. So I will denote the final temperature with theta 3, and this is what we are asked to find. And at this point of temperature, none of the liquid is gaining or losing it. So how do we do this? We understand that Q is equals to MC theta. MC change in theta, sorry. So this is it to find the heat loss. Okay, to find the energy, that's heat energy, is going to be mass times specific heat capacity times change in temperature. And also to find the heat capacity here is also mass times specific heat capacity times change in temperature. But if we had to look at the assumption, that is given anytime we calculate heat, especially if the substance is lagged, we are meant to understand that heat loss is equals to heat gain. That's the concept when you calculate any equation on heat. The heat lost by the first medium must be equals to the heat gain by the second medium. So now I'm going to say heat loss is equals to what? Heat gain. Heat loss. Okay, so what is heat loss? Heat loss is going to be MC change in theta for the first liquid, and its gain is going to be mc change in theta as well for the second liquid. So let's substitute. Now, both the mass of the first one is 2. The specific heat capacity is not given, but it's of the same liquid. So whatever you have as specific heat capacity here is also the same thing because it's the same liquid you're mixing. Now, the change in temperature. The change in temperature for the first medium is going to be 61 minus theta 3 because it is losing. You have 61 minus theta 3. Okay, so the same way here, the mass of the added quantity of liquid is also 2, and the specific heat capacity is not given. That is C for the same liquid, and the temperature here is going to be theta 3 minus 21 because this is the side that gains the heat. So if you lose heat, your temperature is definitely greater than the final temperature. If you gain heat, is going to be lower because you are gaining the heat. And so 2 divide 2, this divide this. So we have left with 61 minus theta 3 equals to theta 3 minus 21. If you collect like term, 61 plus 21 equals to theta 3 plus theta 3. And this is 82 equals to theta 3. Divide both sides with 2. 41 degrees Celsius, which is theta 3. So the option here, option D, is the correct option, 41 degrees Celsius, and that is the final temperature of the mixture. And at this temperature, both liquid will be what? Stable. Okay, so thank you.